Welcome to Asian Teachers Maths. Today we'll talk about decimal and percentage, and we're focusing more on decimal. So we are using them on our everyday lives literally. For example, this is like the price tag. This is like a little cake that costs $3.25. Or you can say it's $3.25. So let's look at the decimals in details and actually see how our number system are being set up. So in the 3.25 that we see, they actually align in a way that their positions tells us about their value. So the number 3 here is the unit digit. This is a decimal dot. It's always at the bottom right of the unit digit. So for unit digit, the value it is showing. This times 1 does nothing. So this 3 actually a 3. And this 2 is less than a 2 because we see a decimal dot here. This is on the right of the decimal dots. It's the 10th digit. So for 10th, we have to multiply the 2 that as shown by 1 over 10. This is less than 1. This is 2 over 10. So it's like 1 over 5 of a dollar or of the unit. And here, the 5 is even smaller because it is on the right of the 2, which is like 2 digits on the right of the decimal dot. And it will mean that the denominator here has 2 zeros. So this is 5 times 1 over 100. This is like cents. This is like 5 cents. This is like 20 cents. So then we have $3.25 or 3.25 of any unit. Okay. So actually this is not something new. We are already using it before we know about decimal numbers. For example, this is 413 or 410 and a 3. The 3 is the unit digit. So the 3 is times 1. The 3 is actually the 3. And the 1 is on the left of the unit digit. 1 position on the left. So we have 1 0 here. So this is 1 times 10. Then this is a 10 because this is here. And this is a 400 because this is here. So this is a 400 and a 10 and a 3 or 413. And so if we look at everything together, the values of digits are actually arranged in indices. This is the unit digit, so this times 1, unit is times 10 to the power of 0. Any numbers to the power of 0 is 1. So we see 3 times 1 here, this is a 1. Which is 3 times 1 here, and then 1 times 10, 4 times 10 to the power of 2, which is 100. So with 400 and 10 and 3, which is 413. Then on the right hand side of the decimal dot, we have the 2 times 10 to the power of -1. This is 1 over 10, like here. And this is 5 times 10 to the power of -2. This is 7 times 10 to the power of -3. So if we use fraction, on the right of the decimal dot, we have these 2 fractions added together. And the sum of these 3 fractions is 257 over 1,000. So any decimal numbers can be expressed as an integers and a fraction like this. And the fraction's denominator is always a 10 to the power of something, 10 to the power of an integer. So like here 2, 1, 0, -1, -2, -3, and so on, can be extended on both ways, or to the left or to the right. So the mathematical system that we're using, or the number system that we are using, is actually a position number system, or positional number system. The unit digit is the reference position. So unit digit always has the decimal dot at bottom right, if there's decimal numbers, or the unit digit is the digit as the right hand side, or rightmost, if it is not decimal. So it gives us reference to which digit is the unit. If it is the unit digit, then this is 2 times 10, or 20. This is unit digit, so this is less than 1. This is 4 times 1 over 10 plus 9 over 100. So this unit digit on the left is larger. This is 3 times 10. On the right, it is smaller. So this is 2 times 10 to power of -1, or 2 times 1 over 10. And sometimes some digits do not carry any values. In these two numbers, there are 5 digits. Only 3 of them has a value. However, we have to show the position relatively. So we have to fill up the zeros even if the digit has no value. In here, we know that the 4 is a 400 and this 4 is a 40 because of the position of the decimal dot and the number of digits we counted since we arrived at 4. So we know that this is the unit digit, 3 here is the unit digit. Then on the left, 1, 2. This is 4 times 10 to the power of 2. Okay. And here, this is a unit digit, 3, and we count 1. This is 4 times 10 to the power of 1. So actually, we are already doing this already, but just that we may not be like looking at this like this, but we are already doing this unconsciously. So how do we do the addition and subtraction for the decimal numbers? So let's do the one without decimal first. So we have 465 plus 27. So 5 plus 7 is 12. So we have 2 here. Oh, this is a 12. So it's add 1 to this digit. Or you can say this is 65 plus 7. That will be 72. So we have a 7 here. And 7 plus 2 is 9. 4, this is nothing. So we have 4. So we don't fill up 0 here because it's not necessary. And then similarly, this is 4.65 plus 0.27. So we have 65 plus 7 here, which gives us 72, like 72 here. So we have 2. This is 7. So 7 plus 2 is 9. 4 plus 0 is 4. And decimal dot is carried over. So as long as we line up all the digits on the same position correctly, then it is the same thing. Yeah. So similarly, let's do some subtraction. This is 51 minus 9. We will have a 42. This is a 2. This is a 4 now. So 24 minus 7 will be a 6. So, wait, 24 minus 7. It's a 7, sorry. Yes, it's a 7. Okay, this is a 7. With a 7 with a tail. Okay. So, we have 7 here. And then this become a 1. So there's nothing here. So because 24 minus 17 is 7, and there's nothing left. Okay. You can also say this is a 250 minus 170. Then we have a 80, but it's actually 240 minus 170. So we have a 70 here. Okay. Then similarly, 1 minus 9, or 1 minus 9. So actually we can do this in another way. So 1 minus 9, it is a 2 of difference of 2. Then this become a 4 because we have 1 minus 9 here. This is a 4. 4 minus 7. Then if we have a 7, this become a 1. Then this is nothing here. However, the big difference between these two, we have to add in the 0 point here, because the unit digit is always present. We always need a unit digit even if the value is 0, because we are using a positional number system. So the unit digits must be shown to show the relative position of all the digits. So we have talked about summation, talk about difference. So let's talk about multiplication. So 15 is multiplied by 0.28. Okay. So how to calculate this? So first of all, we turn the decimals into fractions, or we can just use a calculator, of course, always. However, I will show you the way how to do it by hand. So we turn the decimals into fraction here. 0.28 is equal to 2 times 1 over 10 is plus 8 times 1 over 100. So we have these two fractions add together, then we turn them to such that they have a common denominator. So 2 over 10 becomes 20 over 100. Then it's 20 plus 8, so 28 over 100. So we turn it into a fraction. It's 15 times 28 over 100. Okay, next step, we reduce these 15 and 100 are both divisible by 5. So the 15 divided by 5 equal to 3. And 100 divided by 5 is 20. Afterwards, we simplify the fraction further. So both of the numerator and denominator are divisible by 4. Okay. So both are divided by 4, divisible by 4. Then this become 7. And this 20 divided by 4 become 5. So become 5 times 7 over 5. So this will be a 21 over 5. Okay. So 21 over 5 is not 8.4. So 21 over 5 is 4.2. And how do we do that? So this is a correct calculation for 42 over 5, but we want to do 21 over 5 here. So 21 over 5. So this is a unit digit. Very important. We must always find the position of a unit digit. Then this is a 4 then, because 4 times 5 is 20. Is the maximum number closest to 21, but not larger than 21. Okay, it's the largest number closest to 21, but smaller than 21. So we have 20 here. We still have 1 because this is a subtraction. So we have 1 here. So this one, we still want to divide it by 5. So how? We can extend it here. And add a decimal dots because we are using decimal now. Add the decimal dots. Then now we have 1.0 to be divided by 5. And that will be a 0.2 here. This is a 0.2 or 0.2. So we have 0.2 times 5 will be 1. Okay. And then the division is finished. So we have 4.2. So I mentioned 0.2 as 0.2. Actually, if we're using a calculator, if you put in insert 0.2, it will give the same input as the 0.2. We put in 0.2, the same as putting in 0.2. Yeah. So, and actually that means the same thing, because the 0 is for referencing the position. And the dot actually shows the reference as well. However, we never, for 0.2, we must write 0.2. We can't write 0.2 on paper. They'll be wrong. Although we probably understand what this is. But the calculator understands what this is. So, okay. So we show the multiplication. Last, of course, but not least, will be the division. So for division, this is 4 is divided by 0.25. So what is this? So you recall the definition of division. We are dividing into this amount of equal pieces and then take one of the piece, if this is like pizza. However, what does it mean by divide into 0.25 pieces? Is less than 1. With a pizza, you can divide into 8 pieces, 4 pieces, 2 pieces, 1 pieces. But what is 0.25 pieces? And then take 1? So actually doesn't make sense. However, because decimals and fractions can show the same values, and we have defined that if we divide by a fraction, if something is divided by a fraction, it is actually equals to multiplying the inverse of the fraction. You can just switch place of the denominator, the denominator, and then switch the division symbol to the multiplication. Okay, we have defined this. So, which means we can do this division. So in here, 4 is divided by 25 over 800, which means 4 is multiplied by 100 over 25. We simplify this fraction, so both of the denominator and denominator are divisible by 25. So we have 4 times 4 for 1 here, then this is a 16. Oh, actually it's equal to 4 times 4. And when we're doing division, sometimes a situation may occur like this. So 10 is divisible, 10 is divided by 3. So we go on of the division. This is 3, always line up the unit digits. And 3 times 3 is 9. This is a difference of 1. So we still want to divide this 1 by the 3. Then we use decimals. Extend. Decimal dots must be aligned. So, oh, we don't zero yet. This is a 3. Because 0.3 times 3 is 0.9. Okay. And with 0.1 left. Oh, we run into the same situation. Add the 0 to here. Then 3 times 0.03 will be 0.09. Oh, and then we have the same situation again. So we can see that from this pattern, we are getting 3.3 like here. And we have a 3.3 recurring. Okay. So this is a recurrent decimals, and it shows actually this is 3.3 recurring has the same value of 10 over 3. So we can just use the fraction then to avoid using this, because for a recurring decimals, it takes lots of steps to turn it back into the fraction. Okay. So it looks like something like this. So let x be the recurring decimals, 3.3 recurring. Then and 10 is 33.3 recurring. Okay, we multiply this number by 10. Okay. So 10x minus x will be equals to 33.3 recurring minus 3.3 recurring. Okay. We have, so the recurring part is deducted, and this is a 3, so this is 30. Okay, and 10x minus x is 9x. So we have 9x is equals to 30, which means x is equals to 30 over 9. So x is equals to 30 over 9. And which means x is equal to 10 over 3. Because both the denominator and denominator are divisible by 3. Okay, we get back the 10 over 3. Takes a lot of steps, yeah. So just use the fraction. And when we're using calculators, we can't even input the recurring sign. I think some calculators do, but most calculators that I've come across do not have the button or something to let you put in this recurring number. So just use the fraction. Although every calculator, when they're giving answers, they usually will give the decimals answers first. Even in recurring, then we can like press a button to like change it to a fraction. Yeah. So and this is for decimals. We'll talk about a percentage next time, and see you in a tutorial of decimals.